Let's all sit down if possible. Excellent, very good. Thank you. So this is the second lecture. I sent you a script. Hopefully you received it, yes?
Yeah. Yes, sir.
Excellent. I assume that 5 times yes is a collective yes. Is that correct?
Yeah.
Okay, good. So what is really useful is there's a reason. So I'm the bouncer here, yeah? Come in, no problem. So what's really useful that you study these scripts ahead of time, okay? That's why I sent them ahead of time. And I will keep sending them ahead of time. Instead of sending you all the 30 scripts of the remaining lectures, I will just send them to you the day prior. And you might not have time, but just going through it for 10-15 minutes, take your laptop to class so that you can follow what I am doing here in class, okay? Welcome. $5. Okay. ID? No. Okay. Okay. So let's start for today. And there should be a script here somewhere. Here it is. So this script covers pages 15 to 40 of chapter 2, okay? So the quiz next week is about chapter 1 and 2. Now chapter 1, that's useful to read, so please read chapter 1. But there's not a lot of stuff about programming in there. But it's background information, it's useful to read. Okay, the quiz next week is going to be relatively easy. But that's always if you understand the material. But it's just a matter of what we discuss in class is what you're going to get on the quiz. Okay? If things are unclear, please refer back to the book. I try to summarize in each script the most important things in the book. So this script will cover pages 15 to 40 of chapter 2 of the book. Okay? So what will you learn today? Wow, that's a really popular entrance. And it says exit. Is this, I don't know, but in the Netherlands there would be a lock here or so. Yeah? Anyway, the dean is outside as well. Okay, so what you will learn today is scalar variables, we already talked about that on Monday. Vector variables, matrix variables. How to work with the help function in MATLAB. How to work with functions such as linspace, logspace, ones, rand, diag. Subtracting, addition, dividing. The use of colon and semicolon. And built-in constants such as pi. Okay? So, okay, let's start the script here. A scalar variable is simply a variable that consists of a single number. That's a scalar. A scalar is a single number. So, for instance, here on line 18, I can execute a statement that says, I have a variable a, and I declare that that variable is a scalar and its value is 4. So what I write is I write the variable name. I call it a. You could call it anything. Okay? But no spaces. It needs to be all connected together. So you cannot do like I can call this a, b, c, d, e if I like, yeah? Then I have a variable called a, b, c, d, e. But I cannot call it like a and then some space in between because now MATLAB gets confused because now it thinks we have a scalar a and we have a scalar b, c, d, e. And it doesn't know what a is, so you'll get an error like this. So first thing, when you use variable names, always use names that make sense. Okay, for instance, if you write a computer program and the computer program is solving for pressure, what's the current pressure, the atmospheric pressure in Irvine, downtown Irvine, use a variable, for instance, called P, the P of pressure, yeah? Don't call it like my grandmother. Okay? Just so always makes sense to use variable names that say something about the actual variable. So in this case, I just use a variable name a and I say a is 4. So if I now do whose, what I see, I have, oh, I will clear everything else. Bless you. Whose, and then I have a variable name a. Its size is 1 by 1, so we know that it must be a scalar because the size 1 by 1 is a scalar. And the number of bytes and class, we can forget about that right now. Okay? Now I can define another variable called b. Okay, so now I like to compute a new variable. I have a and b. And let's say that a is the amount of money that my mom makes per day. B is the amount of money that my father makes per day, and maybe I, as a child, like to know when can I buy my next Ferrari. So I need to calculate how much do they make jointly together, and then multiplying with time I can figure out, okay, this is how much time I need to buy my Ferrari. So what I do now, I declare a variable called C, and I just say, you know what, C is A plus B. And now MATLAB says, okay, you know what? A was 4, B was 10, so now my variable C is 14. So in a calculator, when you calculate with an old calculator, when I was young, like 1944 or so, yeah, you don't declare variables, you just say 4 plus 10, and that gives you the answer 14. And we can do the same thing here, 4 plus 10, and MATLAB will tell you that that's 14. But now, this is not associated with the variable. The variable is now answer. Okay, ans is now my variable 14. So it's always good to declare variables. So again, a variable consisting of a single number is called a scalar. And obviously, it can be any number. For instance, r is pi. Pi, you only see 4 significant digits over here, okay? 1, 4, 1, 6. But this is much longer. I believe if I do the option format long, and I do pi here, you see now you see many more. So don't think MATLAB calculates really accurately, okay? Up to many significant digits. So don't think that the answer is that what appears over here. This is just for convenience, because you wouldn't like it if there's another 600 significant digit that your whole screen is entirely full. You get completely confused, okay? So pi, okay, is built in and we know what pi is, yeah? Okay, good. Now, so we can add 2 variables together. We can also subtract 2 variables, a minus b. Yeah, that's the same as 4 minus 10, because a was 4 and b was 10. And of course, I can also assign a variable to this. When I assign now my variable d is minus 6. Is this all making sense so far? I see about 20% of the students saying, yes, this makes sense. 80% is looking forward to go to a baseball game or so. Okay, so anyway, so I've now a variable d is minus 6. Okay, so please read what I write in these scripts, okay? So what you see so far is that it might be annoying that, for instance, if I perform this calculation, that each time the answer is written to the screen, imagine that you have a script consisting of 1,000 lines of code, and in each line you calculate something new. Because that's what you eventually are going to do. Believe it or not, you're going to write really long scripts where you start with a few pieces of information, and you make all kind of calculations, and then you have your end result. And you might not want all that information always written to the screen. Now you can suppress output writing if you use the semicolon here behind at the end of a sentence. Okay, if I now do this, you see that d is being calculated, but it's not written to the screen. Okay? Like when you work with Microsoft Windows, yeah, terrible program, but let's say that you decide to work with that. There's a lot of computer coding behind that, yeah? And that you click on certain things and eventually something happens. Imagine they would not suppress output writing to the screen and you would see all the variables that are being calculated, all the names. That's terrible. So that's why MATLAB introduced a semicolon. This depends on the language, but semicolon means no output writing to the screen. So this might be a question next week on the quiz. How do you suppress output writing to the screen? Okay, and these lectures are being recorded sadly, so you just look at them again and you know all the answers, yeah? So semicolon, okay? Don't use this or that or anything else, yeah? Just use semicolon, this, okay? Now, a vector variable, a scalar is a single value. A vector consists of multiple values, either vertically or horizontally. In this case, line 55, I've declared a vector v consisting of 5 values. And this is a row vector, row, column, yeah? So rows going horizontally and columns go vertically. So this is a row vector or a horizontal vector, and it consists of 5 values. So I can copy paste. So if people wonder how I do this, so I press Shift, then I press down, then I do Control C, I do Alt and then Tab, and then I do Control V like this. Some people wonder how I do that. But that is just for people that have an IQ below 60. They figured it out at one point. Okay? So this is my vector, horizontal vector v. And some people do not like horizontal vectors. Okay? So what they do is they think, okay, you know what? Let's transpose my vector. And they use this prime here at the end. And then what happens is, now I have a vertical vector. Okay. So, and of course I can also assign this as a variable where w is now, if I assign this as, if v was horizontal, then w is now a vertical vector, a column vector, because it's v transposed. Okay. Now, obviously, I now have a number of elements. Imagine that I like to know of a given vector, I like to know a certain index in that vector. Maybe I'm not interested in all these values. Maybe I'm only interested in the value in the middle. Now I know that this one has 5 elements. This is element 1, 2, 3, 4, 5. So now I know that, for instance, if I ask for the third element of v, the answer is 3. Because you see, that's the value of 3. If I ask for the third element of w, I'm getting 3. If I ask for the last element of w, I'm getting a 5. So with this statement, round brackets and the index number, you can request a specific value in a vector or in a matrix. And why is it this way? This is just, again, they sat around the table and they're like, oh my God, how are we going to do this? This is just convention. Okay? Now, obviously, now I have a vector this and I have a vector like this. And now I can actually multiply them together. I don't know if you've ever seen this. I don't know if you know what a vector inner product is. But this is also a question, maybe not on the quiz, but then it will be on the exam 1. The inner product of 2 vectors always comes out as a single number. And what is an inner product? In this case, that's a horizontal vector times a vertical vector. This is a horizontal vector, and this is a vertical vector. So how do I get to 55? Let's look at the v. That's 1, 2, 3, 4, 5. And then I have W, which is also 1, 2, 3, 4, 5. What happens with this vector multiplication is I do V1 times W1 plus V2 times W2 plus V3 times W3 plus V4 times W4 plus V5 times W5. So what I essentially get here is, if I write this out, is this times W1 plus V2 times W2 plus V3 times W3 W4 plus V5 times W5. And that's 55. Okay? This is what we call an inner product. So an inner product is always a single number. Okay? And how can this be useful? Imagine that you have some numbers, random 1 to 10, yeah? Let's say I have some random, and I make a format short because this is a little annoying. So I have 10 random numbers between 0 and 1 here. And I like to square each number, and I like to take their sum. Okay? That's typically what's done in a lot of mathematical operations. I have a certain vector, I like to square each number, and then I try to take the sum of all of them. Now what you can do now is R, yeah, times R prime. Yeah? This is an inner product where this one times that one plus that one times that one plus that one times that one. So that's squaring each of them and then taking the sum. So that's the same. And this is a horizontal vector, and this has now become a vertical vector. Do we still follow this? Okay. So this is called a vector inner product. So a vector inner product, and a lot of students do this wrong, is an horizontal vector times a vertical vector. R is horizontal. R prime is vertical. Okay? And so V was horizontal and W was vertical. Yeah? So this was my V and this was my W. So horizontal times vertical vector, that's called an inner product. MATLAB will do the calculation for you instead of you doing this. Okay, but we also have called something that's a vector outer product. Then it's not a horizontal times a vertical one, but it's the other way around. It's a vertical times a horizontal one. So, if I do an outer product, then I have a vertical, I need a vertical vector times a horizontal vector. And now what you see is that you have a matrix. So, inner product, horizontal vector times vertical vector results in a single number. Outer product, vertical vector times horizontal vector results in a matrix. And the size of the matrix are the dimensions, are the number of rows of the first vector times the number of columns of the second vector. And in this case it's 5 by 5. Okay? And matrix algebra will come back in chapter 6, 7, okay? So you can forget about it now, but this is inner product, outer product. Now, what the nice thing is about MATLAB, and we talked about this before, that we can also, I have quickly defined two vectors here, A and B, and they both have 7 elements, and they're both horizontal vectors. MATLAB can now very quickly just take the sum of the two. Okay, bless you, that's not limited to just a single scalar, but here we can define a variable c that's a plus b. So c1, the first element of c, is a1 plus b1. The last element of c is c7, is a7 plus b7. Okay, so you don't have to do number by number, but MATLAB knows if we do it this way, then we can add them up together, pending that they're both of the same size. Okay, we talked about this last time, but if I now have 1 by 8 and b is still 1 by 7, then if I do a plus b, then it's going to complain because both these factors are not of the same size. B is smaller than A. A has one element extra. And MATLAB doesn't know what to do because the element here is unknown, element number 8. So it crashes. And that's what it says here. Error using plus, matrix dimensions must agree. In this case, it's a factor, but who cares? Okay? So these warnings are typically really useful, and that's where practice comes in. Now obviously, once I have computed, if I have my A, and it's 1 by 7, and I have my B, and then I can add them up together, like C, and if I don't like a horizontal factor, I can use the prime again and make it a vertical factor. Okay? Now, we're not only limited to adding, subtracting, we can also actually divide one factor by the other factor. But again, that can only happen if they're the same size. So in this case, A and B are of the same size. They both have 1 row and 7 columns. Yeah? So what I can do is I can just do A divided by B. And this is really important, this dot over here. Because with this dot, if I work with factors or matrices and I like to divide one matrix by another matrix or one factor by another factor, I need to use a dot over here. Because then MATLAB knows that it needs to be done element by element. If you do not do this, then MATLAB will get lost in matrix algebra. Okay? And we will talk about that in chapter 6. For now, just remember, if you want to divide one factor by another factor, you need to use this dot and then divide by. This dot tells MATLAB that it's element for element. So in other words, if I divide C is A divided by B, then C1 is 1.6783, yeah? Now that's the same as A1 divided by B1. Now if I do look at C2 is 13, and that's the same as A2 divided by B2. So you need to use that dot and then that slash. Okay? Dot slash, and that's divide by. Again, you can expect a question on the quiz next week related to this. Okay? Now if I have a factor like phi, I can just say, you know what? I like to square each number of phi. And also here, if I want to square each number, I need to use a dot. So instead of dividing what we did previously, we still use a dot, but now we're squaring each number. So 2 becomes 4, 3 becomes 9, 4 becomes 16, 5 becomes 25. And why again do you need to do this? This tells you that you do element by element. So we start with phi1, we square that, then we square phi2, then we square phi3, then we square phi4, then we square phi5. And again, this is just convention. These are just the things you need to know before you can start working with MATLAB. And it might seem overwhelming now, but after a few weeks you're used to all this, okay? Believe it or not, most students pass this class. Now matrices, we've talked about this. I can create a matrix. I have W and I have phi. Then my outer product was this value, yeah? Outer product is vertical factor times horizontal factor. This is my outer product. This is a matrix now, yeah? And imagine that I like to figure out what's now the middle value of my matrix. Now in this way, I just have to say if I'm talking about the matrix, I now need an indication of the row and the column number. Yeah, if I have a vector like W3 is just the third element. I don't need to indicate that I have this the third row and the first column. It's the same answer. Okay? But because you work with a vector, MATLAB knows, like with V, that V4 is just 4. Okay? That's the same if I would request V1, 4, because row, column, and that's one row, and that's the fourth column. With vectors, one index is enough. But if you now talk about matrices, it's useful that you have first row indicator and then column. So this is the third row, third column. So that's this number. This one is second row, fourth column. Okay? Now, and if I have t and I like to raise this thing to a certain power, to the power 3, I can do that. Again, where I use this dot to indicate element by element. And now what you see here is that 1 to the power 3 is 1, 2 to the power 3 becomes 8, 3 to the power 3 becomes 27, 25 to the power 3 becomes 15,625. So you can do all these things in Excel, yeah? But MATLAB does these things way, way, way faster, honestly. If you're little, and I have students, believe it or not, that after this class, half a year later, I talk to them again. They're still alive, and they really use MATLAB for different classes. So it might be a little bit overwhelming now. There's little I can do about it. Can make 5 more jokes. We have some time left, so that not all of you fall asleep, because that typically happens. Yeah. But this is really useful material. And in the beginning you're like, oh God, how does this all work? This is stressful. Oh, I don't understand. Just practice it at home. Okay? And if my lectures are really bad, which in theory they are, okay, then you can always go online, Google, and you type in Google, and then you go google.com. We know how to do that nowadays, yeah? You see there's already students leaving. And then what you do, you type in MATLAB introduction. And then you get hundreds of PDF files that explain how to work with MATLAB, how it works. Simple examples, they start from the basis, what we're doing now, and they make it more and more complex. Rest assured, the quiz next week is going to be relatively simple. Okay? Usually students do well on that one, and then it's all F from there on. Okay? Now, like I had my fact or my matrix T, which is 5 by 5, yeah? I can create a matrix U, which is random numbers with dimension 5 rows, 5 columns. So each cell has a uniform random number between 0 and 1. And now I have 2 matrices that are of the same dimension. T is 5 by 5, U is 5 by 5. And now what I can do, I can declare a new variable called B is U plus T. And I just add them up together. Again, this is only possible because they're of the same size. Okay? So, and now I can also divide, like I have T and U, I can also divide U by T. Again, U was this, T was this, and now I do divide U element by T. So now, my first element is of this matrix is that's U1, 1 divided by T1, 1, yeah? And so forth. And this is the result you're getting. So these operations, adding, dividing by, subtraction, only possible if they're the same size, matrices and vectors. Okay, very important. Factor inner product, horizontal factor times vertical factor results in a single number. Factor outer product is a vertical factor times a horizontal factor results in a matrix. How do I suppress output writing on the screen? Semicolon. 4 questions on the quiz there. Okay. And obviously I can also, this was my matrix T, yeah. I will clear the screen and start on top, T, yeah. I can also transpose this whole thing. I just used my prime thing. Okay? And now you figure out how this transposing works. Okay? You see that they're not... Nothing happened. And you figure out why. But I can give you another example here. We'll create U again, yeah, and then we do this is U and then this is U transpose. And now you see that something did happen. Okay? So essentially, if I transpose, then the first row of U becomes now the first column of U transpose. The second row of U becomes the second column of U transpose. Yeah? Okay. Now, we have a very nice help built-in function in MATLAB. So we can clear everything out. And with help, and for instance, I like to have some help about a function called rand, because I've used it before, yeah? So what I type help. It's like you call, because you can no longer pay for your mortgage, yeah? So you call up the hotline and you say, help. Yeah, and then you just indicate that you want to talk to a certain person, and this person, in this case, we like to talk to the person rand. So now what we have is help rand, and now what scrolls over the screen is a lot of information about this particular function, and with examples here at the end how to use it, and etc, etc. So for MATLAB has so many built-in functions, and in this way you can get information. What is it that this function does? How do I utilize this function? So a function essentially is something that's built in MATLAB, that something happens in there, but you're not interested really what happens in there. You're only interested in the end result. Like in the case of random, remember I requested here that I like a matrix that's 5 by 5 with uniform random numbers. Yeah? That's my function rand. So the way we typically work with functions, and again more about this later, this is the output variable, is the function name, and then between round brackets, input variable 1, input variable 2, input variable 3, input variable 4, depending on how many input variables that function has. In this case, this function rand, I give 2 input variables. I tell rand that I want 5 rows and 5 columns. I am not interested what happens in that function rand. That's a built-in function. Someone of MATLAB wrote that function. And what comes out are just some random numbers between 0 and 1. So each time I execute this statement, I will have a different matrix with numbers, because it's a random number generator. Okay? Now I can also ask for help a function, the sinus for instance, and that's this function. That's the sine of the argument in radians. Okay? Now, so for instance, if x is, and by the way, there's also help here, okay, here on top, you see? But I have a hacked MATLAB version, okay? So I've never paid for MATLAB. I remember, I can tell that story a few minutes left, yeah? So I remember one time I was in Amsterdam, this was back in 2003. A colleague of mine just finished his Ph.D. and he gave me all his MATLAB stuff. He said, Jasper, you can have my MATLAB license. I'm going to retire. I'm done with my Ph.D. We had, by the way, someone at the University of Amsterdam that retired or like actually got his PhD at the age of 96. Yeah, he outlived 4 of his advisors. And finally, it took him 70 years, he decided to finish. It's really true, okay? But anyway, so this was a younger guy, he was a friend of mine, you know, was one of these persons we sat in the bar with, drink, yeah, never made it to work. So actually, yeah, so he told me, Jasper, here you have my MATLAB version. And MATLAB gives you a personal license, and they have a license number, it's under your name. So at one point, they were installing a supercomputer at the University of Amsterdam, and I thought, you know, I'm going to make use of that. And I was like, God, you know, then I need a MATLAB license for each individual node on that supercomputer. Yeah, I cannot install my version of MATLAB, which was his version, on like 66,000 different processors. No, you need to buy a separate license for each processor. So I called MATLAB. I thought I'm smart, you know, I called him up and I said, like, the guy asked me, okay, so what's your license number? And I already gave him my name. And my friend's name that gave me the license, his name was completely different, yeah? So the guy said, like, okay, so I'm talking to Jasper, and but this license is under the name of Mark. And then things already became a little bit, I started to become a little nervous, because that was the time where they actually started visiting universities to check whether in universities they would have the correct software in student rooms, yeah, and not illegal software, yeah. So anyway, I was talking to him, said, yeah, actually, yeah, he just left, he gave it to me, so after now a story of 5 minutes, and then I asked him, like, okay, you know what, we have a new supercomputer, I do a lot of these calculations in MATLAB, and but that's really expensive, like one license was like $1,000 at that time, okay? So for non-student use, okay, with a lot of toolboxes. And then the guy said, yeah, that's very expensive. Yeah, 6,000 times 1,000, yeah, that's not cheap. I said, yeah, I can give you a discount. 800. I said, wow, you're really generous. Yeah. And then he said at the end, believe it, and I said, but Jasper, why would you want to buy MATLAB? He said, look in Octave. Yeah, Octave. I don't know if some of you have looked at Octave. Octave is the same as MATLAB, but it's open source. It's for free. Yeah? So you can download it on your computer for free. It does 99.5% of the things that MATLAB does. So the scripts so a statement that I execute here works also in Octave. So most of the programs works perfectly, okay? But I was so surprised that someone working at MATLAB would point me to like open source software. I was shocked because I thought, like, you know, isn't he supposed to sell me like 6,000 of those licenses? Yeah, because that's what they do in America, yeah? You go to the store to buy like a bike and you go home with like a new house almost, yeah? It's anyway, so, but that was nice. So then we started working with Octave. So Octave is also something, the installation, you should have the information, okay? Okay, now special functions. Special functions that are highlighted in chapter 1, the function once. And the function once essentially is just, you specify number of columns, number of rows, number of columns. And if you specify once 1, then it's just a single value. Okay? And if you do this, A is once 1, that's not so smart because you better just do this, okay? But if you want to have more ones, then what you can do is you can specify, you know, I want 4 of them in a row. And this function is used a lot, okay? To fill up large spaces with values of 1. But like other functions like rand, you can also create a matrix here. And this is a matrix of 3 columns by 4, 3 rows by 4 columns. Always input variable, number of rows, number of columns. So this is again the function name. This is the output function name, input variable 1, input variable 2. And in this function with ones, we know that input variable 1 is the number of rows we want. And the second input variable is the number of columns. And of course, we can ask help once, and we're going to get information about this function and how it works. Okay, so here I went over all this. Then we have something that's called the identity matrix. I don't know if you ever worked with that. An identity matrix that consists of zeros everywhere except on the main diagonal, and they're filled with values of 1. Okay, so this is what we call an identity matrix. And the function for that in MATLAB is I. Again, a built-in function. They were talking about it, what shall we use for identity matrix? And then one person said, my wife has so many problems with her eye, and whoops, there it was. Yeah? So that's how it goes. And in this case, if you use a symmetric matrix, you can also just do it this way, with one input variable. But I don't want to confuse you too much. These are specifics related to functions. So again, output is function name and then input variable 1, input variable 2, input variable 3, whatever. So this is 5 by 5. But unfortunately, the book likes to confuse students so now and then. And it says, okay, let's build an identity matrix that does not have the same number of rows as the number of columns. So now we ask for 5 rows, 7 columns. So how do we do this? And then it looks like this, where for the first 5, it's fine. But now we have 2 extra rows or 2 extra columns. Yeah, because we asked for 7 that are actually filled with zeros. Okay? So a question might be, in the quiz that you see a certain matrix, and that the question is, which comment generated this matrix? So in this case, you might get something like this, and then the question is, you have 4 or 5 possible answers, which one created this matrix? Okay? Now, not always do we like or do we work with an identity matrix with ones on the main diagonal. We do like the zeros of the off diagonal, but maybe we do not like that the main diagonal consists of ones. The main diagonal is always the vertical diagonal from the upper left to the bottom right corner, okay? Maybe we like different values on there. Now, MATLAB has a different function for that, and that's called diagonal. If let's say that phi doesn't exist anymore, but let's say that I have a variable phi like this, and then I do this statement, diagonal phi, and now I have a matrix. Let's just do this over here. This was my phi, and then I do diagonal v, where diagonal creates a matrix that is filled with zeros, except on the main diagonal, where the values are filled with those that you supply in the input vector. In this case, v is the input vector. Does this make sense? So these are just functions that you should know. And this, again, it gets easier because these things will keep coming back, okay? And that's why, what I said, it takes about 4 or 5 weeks to really digest all this, and then things are getting easier and easier. At the beginning it can be a little bit overwhelming. Now it's all explained here. And imagine that I have that I assign that this is a matrix A. And imagine I have a matrix and I like to extract the diagonal elements again. Now then I can just do this. What's the diagonal of A? And then I have my diagonal elements back. Okay, so there is, let's go back to a vector, okay? So we have our vector phi in this case, yeah? This was our vector. And let's define another vector u, okay? So now my outer product would be u times phi, yeah? And my inner product would be phi times u. Okay, this is important. Please remember that. But my vector u is defined this way, and I define that over here, where I put the numbers horizontal, I use the prime. But that's not necessarily needed. You can get the same as on line 226, where you don't use the prime to sort them vertically, but you use the semicolon in between the numbers. Semicolon means break the line or suppress output writing. Okay? So I can define this matrix U. I can also define that as example, let's create a new one, is R is 2, semicolon 3, semicolon 4, semicolon 5, semicolon, and I want to not write this to the screen, so another semicolon. Okay? So if I now plot R, this is my R. Okay? So if I put a semicolon in between numbers, that means go to the next line. If I leave it out, stay on the same line. Okay? Now what happens if I do this? What's going to happen here? Can MATLAB execute this statement? No, MATLAB cannot execute this statement. And why? Because I specify that that I have a first row consisting of two numbers, 2 and 3. Then I have a second row consisting of one number and a third row consisting of one number. Which means that some numbers on the second column, they're not known. MATLAB crashes. Okay? And that's what you see here. The dimensions are not consistent. So essentially what you have 2, 3, then a 4 and a 5, so you miss two numbers here. So MATLAB crashes. Okay, so now I have a vector phi. Yeah? Let's say that I really do not like number 4. It reminds me of my uncle. Okay? And I really didn't like him. Okay? So you know what? I like to remove that thing. And how do I do that? So I have phi and I like to remove it as soon as possible. What you can do is the following. You say the second element of phi, which is 4, this is element 1, 2, 3, 4. The second element is equal to an empty space. So if I do this, what happens? It's gone. Okay? So this is how you manipulate vectors, how you can remove numbers. Imagine that in this case, you can not only remove single numbers, you can remove entire parts of a vector. Let's say that I don't like the last two numbers now, yeah, but from what is left, I don't like the last two numbers. So what I can do is I could say what 2 to 3 is this, and then I only have the first one left. So here I remove 1, and in this case I remove two numbers, 2, 3. Okay? So we will stop here. We will continue on Friday. Please study the scripts ahead of time. Okay? That's important.